Section 3.4, assignment number 2, number 34. So this is the last problem of assignment number 2, and it is a doozy. Notice there's a lot going on here. Not only is this a composite function requiring the chain rule, this is a triple composite function, which means that we have a function, x squared plus 1, embedded in a function, 2 plus something to the 4th power, embedded in yet another function, something to the 3rd power. What that means is we're going to have to use the chain rule 3 times, or actually twice. So that sounds complicated, but if you approach it very systematically and you're very careful and neat in how you write things down, then it should be a piece of cake. So let's get started. So in order to find g prime of x, the first thing is I need to find the derivative of the outermost function, which is something to the 3rd power. So how do we find the derivative of something to the 3rd power? Well, simple. We take the exponent, we bring it out to the front, times everything on the inside. But instead of to the 3rd power, we're going to do to the 3 minus 1 power, or to the 2nd power, times the derivative of the inside. Okay, and notice that the inside will itself require the chain rule at a further point. So let's bring everything down that we have so far. All right, so to find the derivative of 2 plus something to the 4th power, we'll have to use the chain rule. Here's something that sometimes confuses students. What happens when we're finding the derivative of something plus something? Well, you just find the derivative of each thing separately. That was one of the old differentiation rules, I believe from section 3.2. You might want to go back and review that in case you have forgotten. In other words, the derivative of a sum is basically the sum of derivatives. So what is the derivative of 2? Well, that's just 0. So that goes away. Well, what's the derivative of something to the 4th power? Well, to do that, we bring the 4 to the front. We bring the exponent to the front as a coefficient, times the inside, to the, instead of to the 4th, we do to the 4 minus 1 power, or 3, times the derivative of the inside. So here we have to use the chain rule one more time. All right, so let's bring down everything that we've gotten so far. Times 4 times x squared plus 1 to the 3rd. Now, what's the derivative of x squared plus 1? So again, as before, when we're finding the derivative of a sum, we do the derivative of each thing separately. So what's the derivative of x squared? Well, that's just going to be 2x. Well, what's the derivative of a 1? Well, that's just 0. So we can go ahead and close our parentheses here. Now we just need to simplify as much as we can. And you're going to find out in a few moments that we can't simplify that much. So what can't we simplify? We can combine all of the outside coefficients. So 3 times 4 times 2x. Well, 3 times 4 is 12. Times 2x is 24x. Times 2 plus quantity x squared plus 1 to the 4th power squared, times x squared plus 1 to the 3rd. And that's pretty much all we can do here. Notice, and you might be tempted to do this, but notice that we have an x squared plus 1 to the 3rd here, and an x squared plus 1 to the 4th here. And we might be tempted to try and combine these. However, it's not as simple as that. We cannot just multiply this by this, because x squared plus 1 to the 4th is actually a part of a sum that's being squared. So unless you want to FOIL this and then multiply each term to this, then I think we should be happy with this answer. That's it.